Hello friends, welcome to my channel. Let's have a look at a daily challenge problem, that is problem 13, Roman to integer. So in this video, we are going to share a solution based on the dictionary and check idea. So in practice, we just need to do a linear traversal of the Roman number string. So these statements are mainly about the rules of Roman numbers. So it's sort of well known, so we do not read through the main statement. So the constraints on this problem are the following. So first, the length of the string s is bounded above by 15, and s contains only the atomic characters IV, X, L, C, D, M. So I represents 1 and M represents 1000. So it's guaranteed that s is in a valid Roman numeral range. So let's see, this is the range constraint to this problem. So with that said, let's look at the method here. So the method is the routine dictionary and check idea. So here are the rules for Roman numbers. So essentially there are four or five rules. So first is the set of atomic symbols. So it contains IV, X, L, C, D, M represents 1 up to 1000. So the rule 1 is that we try not repeating an atomic symbol more than 3 times. For example, this I repeated 3 times is good for 3. And in general, we do not write this 4 in this format. 4 I's repeat. So, but in this case, actually, in some clock or watch, this form is still used. So this is rule 1. Rule 2 is that left-small-subtraction. For example, we have I and V, and I is less than V. So the interpretation is V minus I. So 5 minus 1 is 4. Similarly, IX, XL, XC, CD, and CM. So rule 3 is that write small addition. So for example, we have VI. I is 1 and V is 5. So because I appears in the right of V, so the VI is interpreted as 5 plus 1, that is 6. So another rule actually does not complete into this problem is that if we add a line above a letter or numeral, it means multiply by 1000. For example, if we put a bar in M, so it means M is 1000, right? So multiply by 1000, that is 1 million. So actually, the rule here which produce problem is the rule 2 for us to quickly get the numerical value from a Roman string. So the idea is the following. So a solution will be valid if we could take the above rules into consideration. So among the above rules, so rule 2 is the key point here. So all others are basically addition, right? So because of this, we just need to check if we have a valid rule 2 cases in a valid Roman number. Otherwise, we just see the atomic symbols one by one and do addition. So rule 2 actually can be absorbed by a dictionary check. So with that said, I guess we are going to write the code directly. So actually the code itself speaks. So for convenience and to avoid a mistake, so I copied dictionary here. So this dictionary contains the IV, X, L, C, D, M, the atomic characters, and also the cases corresponding to rule 2, so IV, IX, and up to CM. And then we just need to prepare the result for this case. So with that said, so let's do the case. So here I'll initialize I to be 0. So we are going to look at the string s from the first index, and then the answer as the 0. So whose final state is what we want to return. And then basically it's just a while loop. So while I is less than length of s. So what we want to do is that, so we check if I less than length s minus 1. And so we are going to check the relation of the character at index I and the character at index I. So if dict s and si is less than dict, so si plus 1. So this means that we have a case like this, iv, ix, or cm corresponding to root 2. So in this case, we're going to increment the answer by check this string. So si and plus si plus 1, right? Because this corresponds to 2 characters. And then we're going to increment I by 2. So this is the one case. In all the other cases, so we do not have rule 2. So we just need to add the numerical correspondence for the atomic symbol. That is answer add dict si. Then in this case, we're going to increment I by 1. So this is the full while loop and the bulk of the work. And next we just need to return the answer. So that's actually a full solution to this problem. So overall, actually, it's a dictionary check table and then a linear traversal. So with that said, I guess let's first do a special case check. Yeah, it passes the example 1. This is a very simple case. So now let's do the generic case check. Yeah, it passes all the generic case. So I guess for this problem, that's about it. So for sure, actually here we are doing the problem from Roman numerals to integer. So we're going to do another, that is the reverse, from numerical value to the Roman string representation. That is problem 12. Please check out the next video. Thank you very much.